Swayam Prabha. Digital India. Educated India.
Today, we bring you an inspiring conversation with the brilliant minds behind a breakthrough in sustainable engineering, the development of rare earth free high efficiency motors. Their work not only pushes the boundaries of efficiency and performance, but also opens new possibility for affordable, scalable, and eco friendly industrial and mobility solutions. Let's welcome the innovators who are powering progress responsibly, efficiently, and boldly. So, welcome to the studio, innovators, my dear friends. How are you doing? And introduce yourself first.
So, Vanakkam, this is Team Electris. We are the winner of Smart India Hackathon 2024 and 2025. In the Smart India Hackathon 2025, we got the problem statement from the Ministry of Department of Science and Technology. The problem statement of working on the radar-free high-efficient motors, which we have been working on like 3 years from now. So, it's been a great journey participating in the Smart India Hackathon and winning it. So it was on like a maintaining history all from the 2024 and 2025. In these years, we have learned a lot, and it was a great initiative to collaborate with the ministry and a lot.
Okay, great. So, let's hear from your other teammates.
We are Team Electric and myself, Shushmita.
And myself, Mukesh Kumar.
We have been part of this team for the past 2 years and we are consecutive winners of SH 2024 and 2025.
You must be very thrilled and happy about it. Great. So, let us start talking about the winning idea of yours. I mean, what exactly was that? How did all that happen? So, let's begin with the problem itself. So, what was the problem that you were dealing with, and why were you so, why did you actually choose to, take up that problem? Was there a reason behind it? So, let's talk all about the problem first.
So basically, the problem we are trying to solve is that India majorly imports the rare earth magnets from the other countries, so namely like China and other countries, which is a majorly and very big issues in the upcoming years because there has been like scarcity for it, and it is also not a sustainable option for an electric vehicle or an automotive or whatever field could be. Like for motor field, it is not a sustainable thing. While we have to switch from the permanent magnet motors to the rare earth free motors. So while switching, we do have other cons like there won't be like sufficient magnetic density that we won't be getting. So to replace it, we are going with the ferrite magnets, which are like abundantly available in India, and also we have changed to novel coiled components. Basically, this is the core problem that we are dealing: the cost of it, and also the exporting and importing issues of it. So which also creates like a geopolitical issues. Solving it is a very big issue in the upcoming years. So for developing a solution is a crucial thing. So that's where our problem stands, and we have given our solution to the Ministry of Science and Technology.
Right, great. You rightly said it's not only an issue of sustainability, but also has become a geopolitical issue, and a lot is riding on rare earth materials now. So now let's talk about the solution of yours. So how did you come up with, what exact solution did you come up with? And then let's see how did you break that code.
The solution we proposed was we replaced the rare earth magnets like neodymium magnets with ferrite magnets.
Actually, we bring back the novel coil topologies and replacement of the rare earth metals like ferrite magnets to bring back the efficiency of the rare earth magnet motors. It will be efficient and advancement to it.
So how exactly were you able to, get the replacement of rare earth metals? What other materials did you use, and how were they in terms of compatibility, suitable for the motors?
Yes, as Mukesh said, while coping up with the same efficiency as like the neodymium magnets, the rare earth material majorly consists of like neodymium magnets and other rare earth materials. So majorly it is like a neodymium things. So replacing the neodymium is the biggest challenge because it has higher magnetic flux density. So if we want to replace it, we are gonna go with the option of ferrite magnets. Ferrite magnets are also called as carbon magnets. So if we are choosing the carbon magnets with the low magnetic flux density, there should be also some changes that should be made to the coil. So we have completely eradicated using the iron materials in it. So if we could reduce the usage of iron in a motor, which would reduce the weight of the motor up to like 80%. And also we could reduce the other namely losses like core loss and hysteresis loss and other few losses in it, hysteresis, eddy current losses and other losses in that motor, which is like coming from the traditional valves. And also, if we want to go look after into the cooling part of the motor, it is easy to cool the motor while we go for an like air core motor. Air core motors, like we could spray it with the air cooling technologies or like forced air technology. Even the heat development in the coils are like very minimal. So if you want to replace the magnetic like iron materials in it, we need to choose another material for it. So we have chosen the epoxy resin, which provides like a mechanical structure for it, also gives an insulation property, which increases the lifetime of the stator coil of the motor. So these are the things that we have replaced it so that we could achieve the I5 and I4 class of efficiency.
Okay,
So this is
yeah, so if a common person has to understand the difference between a ferrite motor and a regular one, so how do you put it across in terms of like various elements and usages and efficiency, everything?
apart from efficiency, there are like cost constraints too. The cost of the motor reduces like more than half in these comparison. So ferrite magnet axial flex motors, like they are in half the cost of the motor, which are like in the neodymium magnets. Most of the cost is consumed in the permanent magnets from the neodymium and also from the copper. So if you could cut down the cost of the neodymium magnets and also you reduce the material usage of copper, which is also an rare material in the upcoming days. So if you could reduce the usage of both of these, this would be an additional in a motor manufacturing way to be an additional to the reducing the cut down in the cost of it and also easy manufacturing of it. So these are the things we are focusing apart from the efficiencies.
So coming to the efficiency part, so how sure are you that efficiency wise these are either similar or better than the earlier motors which were using rare earth magnets?
Of course, we have like validated it in the 5 days of the hackathon. We have built it from the scratch. We simulated it in the ANSYS for the air core axial flex ferrite-based magnet motor, and also we have built it throughout the team. One team has been building the simulation, another team has been working on the prototype of working prototype of it, and we have also demonstrated the 200 watt of motor there. So we have validated our solution and also checked the efficiency in the hackathon itself, so that we could say that this is the actual efficiency. We have achieved around like 94.95 efficiency in the hackathon time, and we are also planning to upgrade the versions of it and achieve more efficiency.
Okay, now coming to the creation part of it. So as a team, how did you come together and who all contributed in which manner to bring up the solution?
I'm the team lead of this thing. So basically, we have just formulated an idea, which we have been already working on the permanent magnets. We have been working on the permanent magnets. So we got an idea. Why don't we replace it with the ferrite magnets? So me and Mukesh Kumar have been working on it for like a few years. So we just planned it, and we have gathered a team of like SIs 2024 too. They are like highly like professional people and also like knowledgeable people. They are quick learners. So we stepped into it, and Sushmita took care of the ESC part, the electronic speed control and the control of the motors. And Ritika Bhaskar, me, and Mukesh Kumar worked on the hardware prototyping, and Edumalai Sami and Vishnu Taran worked on the simulation parts. So this is how we have just come up.
Okay, great. So while the competition were on, so tell us in stages, like how did this progress? Like from the mentoring rounds, so were there changes being asked for, or were there modifications being done at your end or at the mentors end? They were like happy or not happy about certain things. So how did it all go?
Okay, during the 5 days of the hackathon, at the first day, we shown the judges as a proof of concept. Our concept is perfect and it will be workable model. That proof of concept will be shown to the judges, and they said, okay, you are right, you can proceed to the next prototype developing model. Okay, then we developed our prototype. We have started to develop our prototype model in the consecutive days, and we first shown the judges as a generated model. is the motor is running a motor as a generating action. To prove them as it is workable. So after the reviews and the suggestions from the judges, we sort out some logical errors and we further developed it more. And at the final day, we developed our prototype and we showed the judges.
On the talk about the mentoring sessions, our basic strategy was we plan to impress some judges mainly in the mentoring sessions. So we showed the judges most of our progress in the mentoring session so that the mentors can spend a lot of time in our working table.
As Sushmita said, our mentoring session was very good because all of the mentors helped us in every step, like insisting this was the method you should do and improve your design, improve your architecture. All the way they were helped more. It was very helpful in our mentoring session.
Yes, we got mentors from mentor and jury from both the academic as well as the industry side. So we could refine our project both on the basis of theory and also like in the practical basis. So we have just balanced it in both the simulation basis and the hardware basis. That's where we could achieve the results in the short span of 5 days. It was much more helpful. Yes.
Okay, the prototype that you produced during the SIH, so what power was that of? How powerful was that motor?
It was rated for 200 watts and it produced torque of like 0.5 to 0.7 newtons.
Okay, so obviously being in a competition and given such a short span of time to develop it, 200 watt is like what would be expected. But the question here is, did the judges also ask this particular question that if you have to go for a higher wattage, I mean, till what point can you go to create a similar kind of a motor?
Of course, since the machine is rated for 200 watt, it has to withstand within the limit of 200 watts. But for proving the scalability, we have also done the simulational parts and show the scalability and easy modular production of the motor, so that they could get convinced on the easy production of it and the scalability of the motor. So this motor should be scalable up to a minimum of like 50 kilowatt to something. So it is a target. So showing the rating, so we have done the simulation for like 5 kilowatt motor and the next day of the hackathon. In the second to third day of the hackathon, we have shown the scalability of the motor in the axis. So they got convinced with it. So they believed it wasn't like a scalable thing. If it could be done in under 200 watts in the 5 days of span from the scratch to the theory to the prototype, this can be built in like 5 kilowatt to a 50 kilowatt, whatever the rating it could be. Since the axle flex are not that much familiar in the market, since it is in like more or less in the theory basis in the current market state according to the India and the few regions. So very few are implementing the axle flex motor. That too, and coreless and permanent magnet free axle flex motors are like not in the market and not in the research too. So we are bringing up a product which is not in the current research to a prototype. That's a big thing. They have appreciated us much in the hackathon. Yes.
Okay, since it was a hardware edition of yours, so the 5 days must be very grilling for you. So how did you cope up with all the pressure and come up with a trump card which gave you the ultimate prize?
We have been working on the core problem statements which have been given by the college infrastructure of AICTE Idea Lab. We have worked much there and we got some experience there. Using those experience, we could solve the problem statement on the spot, and we have also developed our solution in the upcoming days of from the first year. We got we need to select an idea in the first year for Ideathon, and we need to build it in the each year for scaling up it from the idea to a prototype. So for that, we have developed a similar thing, which is like a permanent magnet axle flex motor. So we are just permanent magnet of neodymium axle flex motor. So we are just going to replace it with the ferrite. So in that implications only we have to solve. So which is also in problem statement we have already worked on. So it was much more easier for us as a fresher, and our college supported it too. So that's where we could win for the continuous years. Yes.
Okay, great. So you've achieved a major feat in your life now, in your academic life as well. So from here, where do you go? Where do you see yourself? What is the future of this innovation of yours? Where do you want to take this?
So we want to take part in the innovation of the India and make in India too. So we are planning to take this as a startup and work on it. So we are going to scale this as a startup and do some R&D, and we are eagerly waiting to launch this into the market. And also we are looking up for some partnerships and tie-ups in it, both as the company and institution wise. In the phase of looking for funds and improvising a prototype into a market ready thing.
Okay, so any efforts from your side, have they already been on? Have you started working towards that already?
We are working on it, and we are started applying for the funds and looking for funds and investments too. So once we are once we get the funds that we are looking for, we will be working on the R&D. Still, we are working on it, but efficiently we could work only when we receive the funds and investments and some guidance too from the industry as well as the like seed fundings and ventures. So if we could get the right into the track and we could get the things into the track, yeah, we could work on it.
So I'm sure you'll get all that support, because what you've come up with is something really appreciable and something which is extremely useful and could tackle a lot of energy solutions, energy problems of the country. So I'm sure you will hit the jackpot here. Going forward, you will meet success. And thank you so much for joining us today and sharing all your innovations and bright ideas with us. And wish you all the best. I'm sure you will definitely see the face of success very, very soon. Thank you.
Thank you.
It was indeed a pleasure to meet our innovators and know about their vision, perseverance, and commitment to create solutions that balance performance with environmental stewardship. Their work reminds us that meaningful progress happens when creativity meets purpose. Thank you for joining us for this inspiring session. Until next time, let's continue to celebrate ideas that drive change and power a better tomorrow.